So in this video, I am going to explain about synopsis of environmental chemistry and also worksheet questions. We'll discuss one by one. So first the concept, that is synopsis. So in this lesson, we are discussing about definition terms and environmental pollution. Environmental pollution. This topic will not be there. Environmental pollution. That means air pollution, water pollution, depletion of ozone layer, total. Next. So a definition terms. So first, pollutant. The substance which is present in nature and causes pollution. Which is already present in nature, atmosphere, which causes pollution. Contaminant. The substance which does not occur in nature but releases due to human activity and causes pollution is contaminant. So that is difference between pollutant and contaminant. COD, BOD, very important. The amount of oxygen required to oxidize organic substances present in polluted water is known as chemical oxygen demand, which is COD. BOD. The amount of oxygen used by suitable microorganisms present in water during 5 days at 20 degrees centigrade is biochemical oxygen demand, BOD. So this topic is very important. The BOD value for clean water is just 1 ppm. Clean water means pure water. BOD value for municipal sewage 100 to 4000 ppm, parts per million, very high value. So municipal sewage means highly polluted water. BOD value for normal polluted 17 ppm. So the medium which can react with pollutant is known as sink. Very important, sink. So oceans are important sinks for atmospheric CO2. So they can interact with CO2 of atmosphere. So BOD values are very important. Clean water 1 ppm, municipal sewage 100 to 4000 and polluted water 17 ppm. Next. So TLV, threshold limit value, permissible level of toxic substances or pollutants in atmosphere which affects a person adversely when he is exposed to this for 7 to 8 hours in a day is known as TLV. The permissible level of ionic, that means toxic substances or pollutants in atmosphere which affects a person adversely when he exposed to that atmosphere 7 to 8 hours in a day, TLV. Next, receptor. So receptor means the medium which is affected by pollutant. That means irritation caused by smoke. Speciation. Speciation means the detection of different chemical forms of pollutants. That means whether it may be inorganic or organic pollutants is known as speciation. The detection of different chemical forms of inorganic, organic compounds present in environment causing pollution. Next. So as the BOD value increases, pollution increases. Next, as the COD value increases, pollution increases. Next, as dissolved oxygen increases, pollution decreases. So dissolved oxygen is pure. If amount of oxygen water increases, that is somewhat pure water. If dissolved oxygen increases, pollution decreases. Next, if TLV increases, pollution decreases. So that means COD, BOD are directly proportional, dissolved oxygen and TLV are inversely proportional. Remember like this. Next, environmental pollution, greenhouse effect or global warming. The process of increase of temperature of surface of earth is greenhouse effect or global warming, rising temperature of earth's surface. So greenhouse effect is caused by CO2, O3, chlorofluorocarbons, water vapor. Next, effects. It leads to melting of polar ice caps. Next, increase in global warming, that means due to increase of temperature of Earth's surface. See here, increases infectious diseases like dengue, malaria, yellow fever, etc. Next, acid rains. Sulfur dioxide and nitrogen dioxide after oxidation and reaction with water produces corresponding oxo acids of sulfur and nitrogen, that means sulfuric acid and nitric acid, which can cause acid rains. So acid rains due to oxides of nitrogen and sulfur. So pH of rainwater less than 5.6. So due to acidic nature. Next, effects of acid rains. So it washes away nutrients needed for growth of plants. Next, it causes respiratory problems in human beings and animals. Next, it corrodes water pipes, resulting in leaching of heavy metals like iron. Leaching means dissolution. Next, it damages life of buildings. Next, different types of smog. Classical smog is mixture of smoke, fog and sulfur dioxide. Next, ozone, nitric oxide, acrolein, formaldehyde, peroxyacetyl nitrate are common components of photochemical smog. So remember here classical smog and photochemical smog. Next, effects of photochemical smog. So it causes severe health problems. It also causes corrosion of metals, stones, building materials. Next, PAN is peroxyacetyl nitrate. It acts as powerful eye irritant. It is very important. Next, ozone hole. So depletion of ozone layer commonly known as ozone hole depletion. Here O3 will be converted to O2. Next. So depletion of ozone layer causes skin cancer, cataract, damage to fish production. Next. Sodium chlorate, sodium arsenate, aldrin, dialdrin are responsible for water pollution. Next, eutrophication. So the water becomes over nutritious when organic substances from agriculture and industry are thrown into water resources like ponds and lakes. So due to this, excess growth of algae takes place. So next we will discuss worksheet questions one by one. We will discuss first question. So biochemical oxygen demand BOD is measure of organic materials present in water. So BOD value less than 5 ppm indicates water sample to be. So BOD value less than 5 ppm indicates that is somewhat pure water. It is rich in dissolved oxygen. dissolved oxygen. Therefore, option A. If it is greater than 17, highly polluted water. So, highly polluted water, BOD will be greater than or equal to 17 ppm. Very, very important. Less than 5 means that is somewhat pure, that contains dissolved oxygen in it. Option A. Next. The irritant red H in traffic and congested places is due to. So it is due to oxides of nitrogen. So here NO2 is highly poisonous. And has a deep red color. So here oxides of nitrogen means either NO or NO2. Here NO2 is highly poisonous gas and it has a deep red color, reddish brown. So when mixed with NO2 mixed with aerosols, it causes reddish brown colored haze. So therefore it appears red haze. So D is the option. NOx means either NO or NO2. NO2 is highly poisonous and it has reddish brown color. When it is mixed with aerosols, it causes reddish brown colored haze. Next. Identify the reactions that occur in photochemical smog. So in photochemical smog, so reactions occurring second, third, formaldehyde formation, next to fourth, taking place in photochemical smog. So therefore option A. So components are nitrogen oxides, formaldehyde, next acrolein, PAN, peroxyacetyl nitrate. These are the components of photochemical smog. So methyl alcohol is not component of photochemical smog. So except one, remaining all are components. Next. So municipal sewage BOD value in ppm. Municipal sewage BOD value, highly polluted water. Highly polluted. Therefore BOD lies between 100 to 4000 ppm. For option B. Next. Identify the structure of compound which is responsible for Bhopal gas tragedy. That means NCO. So methyl isocyanate. So which is commonly known as MIC gas. Methyl isocyanate gas. It is responsible for Bhopal gas tragedy. Option B. So green chemistry refers to the reaction which reduce the use and production of hazardous chemicals. That means dangerous chemicals. Just a definition only. So option A. Green chemistry refers to reactions which reduce the use and production of hazardous chemicals. That means dangerous chemicals. Definition of green chemistry. Next. So acid rain is caused by presence of X and Y in air. X and Y respectively are. So acid rains due to oxides of sulfur and nitrogen. So here we can take first sulfur dioxide SO2 first undergoes oxidation, next reaction with water. So 2SO2 plus O2 plus 2H2O gives 2H2SO4 sulfuric acid. Next, similarly NO2 plus O2 2H2O. So here also 4NO2 gives 4HNO3. Sulfuric acid and nitric acid are responsible. Therefore, A. So first oxidation and reaction with water, they can produce sulfuric acid and nitric acid. These two are responsible for acid rains. Next. The non-biodegradable waste formed in fertilizer industry is gypsum. Gypsum. It is CaSO4 2H2. It is insoluble in water, therefore non-biodegradable. Option C. Calcium sulfate dihydrate is gypsum. Next. So which of the following forms holes in ozone layer? So chlorofluorocarbons CF2Cl2. Chlorofluorocarbons CFCs are responsible for depletion of ozone layer, that is holes in ozone layer. So here are the reactions. So CF2Cl2 in the presence of sunlight gives Cl radical plus CF2Cl radical. Next, the Cl radical combines with O3 to form ClO radical plus O2. So the ClO radical combines with O radical to form Cl radical plus O2. These are responsible for depletion or ozone hole. Radical mechanism. Cl radical is responsible for depletion. Next. So which of the following statements are correct? So here make it just CO. So oceans are sinks for CO2 is correct. CO is incorrect. So A is wrong. Next. Greenhouse effect caused lowering of temperature of Earth's surface. That is also wrong. To control CO emission by automobiles, usually catalytic converters are fitted into exhaust pipes. That is correct. H2SO4 herbicides and insecticides form mist. So C and D are correct. So here option A. Option A. Option A, C and D. A small correction. C and D. Option A. Very, very important. Next. So which of the following is not a greenhouse gas? So O2 is not a greenhouse gas. Remaining are greenhouse gases. Next. So which one of the following is not a common component of photochemical smog? You know, O3, acrolein, that means ozone. O3, acrolein. Acrolein means vinylaldehyde. Peroxy acetyl nitrate, which is commonly known as PAN, or components of photochemical smog. So here option D should be there, option D. CFCs are not common components. D. And answer CFCs. Chlorofluorocarbons. CFCs. So option D. Chlorofluorocarbons are responsible for ozone layer depletion. These are not components of photochemical smog. Remaining are components. Next. The photochemical smog does not generally contain simple SO2 not present in photochemical smog. It is the component of chemical smog. That means classical smog. Classical smog. Therefore, option C. Nitrogen oxides and formaldehyde are components of photochemical smog. So NO, NO2 and formaldehyde. These are components of photochemical smog. The greenhouse effect is because of the presence of gases which in general are strong infrared absorbers in the atmosphere. They can absorb IR radiation. Therefore, temperature of Earth's surface increases. Clearly, option A. Next. So, which of the following is not involved in the formation of photochemical smog? Here, O2 should be there. O2. So, hydrocarbons, NO, SO2 and O2. O2, write it O3. Take it O3. So hydrocarbons, NO and O3 are components, but here SO2 not involved in the formation of photochemical smog. So very important. It is a component of classical smog. Classical smog. Therefore C. Next. The disease caused the high concentration of hydrocarbon pollutants in atmosphere is C. Cancer. Direct question. The disease caused by high concentration of hydrocarbon pollutants in atmosphere that causes cancer. Option C. Next. So here some reactions of NO2 are given. How to balance. First NO2 in the presence of sunlight, that gives NO plus O, nascent oxygen. This is Y and X. Next, this O combines with O2, that is A, gives O3, which is B. Now check the option. X is O, Y is NO, A is O2 and B is O3. Option A. NO2 dissociates to NO and O, that O combines with O2 to form O3. Next. Correct statements about smog. So both NO2 and SO2 are present in classical smog. That is incorrect. So classical smog also has high concentration of oxidizing agent. That is also wrong. NO2 is present in classical smog. That is also wrong. Photochemical smog has high concentration of oxidizing agents. So in photochemical smog we have O3, powerful oxidizing agent. So therefore option D is correct. So photochemical smog oxidizing in nature. And classical smog reducing. So here oxidizing due to O3 and here reducing due to SO2. Very, very important. Option D is correct. Next. So formation of photochemical smog involves the following reactions in which A, B, C are respectively. We have to write equations here. So first NO2 in the presence of sunlight dissociates to NO plus O, nascent oxygen, which is AB. Next. So B combines with O2 to form O3. Here this is B and C. Next again NO plus O3, which is A and C, gives NO2 plus O2. So what are A, B, C? A is NO, B is O and C is O3. Therefore option B. Reactions of photochemical smog. So NO2 is reddish brown gas, NO is colorless gas. Next. So X, Y, Z in the following reactions. So ClO radical should be there here. ClO radical plus NO2 gives X. X on hydrolysis gives Y and Z. So here X compound is, so here also it is having one unpaired electron, odd electron molecule, ClO and NO2. This is X. And it dissociates to HOCl plus HNO3. Check here. So X is ClO NO2, Y is HOCl, Z is HNO3. Option B. Yes, this is addition compound. Addition compound. Next, the industrial activity held least responsible for global warming is. The industry activity held least responsible for global warming is. That means in which case global warming will be minimum. So in option C, production of urea. Production of urea. Urea is NH2 CONH2. It can be prepared from ammonia and CO2. Therefore, least responsible for global warming. Option C. So it can be prepared from ammonia gas and CO2 gas. 2 moles we can take NH2CONH2. So plus H2 urea. Least responsible. Next. So which are the following reactions not part of breakdown of ozone in stratosphere? Check here. First take chlorofluorocarbon CCl2F2. In the presence of sunlight gives Cl radical, CF2Cl radical. So next Cl radical combines with O3 to form ClO radical plus O2. Next ClO radical combines with O to form Cl radical plus O2. So which is not involved. Not involved means C option. C option not involved. Here dot should be there. C option not involved. Next. So the delicate balance of CO2 and O2 is not distributed by. That means not disturbed by. The delicate balance of CO2 and O2 is not disturbed by respiration. Balance of CO2 and O2 is not disturbed by respiration process. Respiration. Option D. Next. So which are the following compounds is an example of freon? Freon means CF2Cl2. It should be CCl2F2, chlorofluorocarbons. That means option A. CCl2F2, chlorofluorocarbons, commonly known as CFCs. Freons means chlorofluorocarbons. The radical mainly causes ozone depletion in the presence of UV radiation is Cl radical. Cl radical is responsible. CF2Cl2 in the presence of H nu produces Cl radical plus CF2Cl radical. The Cl attacks O3 to form ClO radical plus O2. So the ClO radical combines with O to form Cl radical plus O2. So Cl radical is responsible for depletion. Option C. So here OH should be there, OH radical. Next. So which are the following are greenhouse gases? Greenhouse gases. So clearly A. Water vapor, and B, O3 are greenhouse gases. Option D, water vapor and O3, greenhouse gases. Next, the possibility of photochemical smog formation will be minimum at. So minimum at. So photochemical smog conditions will be formed in warm, dry and sunny climate. Very, very important. That means during summer it will be formed at high temperature. So therefore D will be minimum. Srinagar, Jammu, Kashmir. So low temperature will be there. Next. So Cl radical attacks CH4 hydrocarbon. A and B are here CH3 radical plus here one Cl, right, like this CH3 and H dissociate like this. HCl will combine to form HCl. CH3 radical will be formed. Therefore, this is A and B. Option C. So methyl radical. Methyl radical or methyl free radical. Next. The photochemical smog does not generally contain. So NO, NO2 and HCHO are the components of photochemical smog. But SO2 is the component of classical smog. Therefore, SO2. Next. So the acid that is believed to be mainly responsible for damage of Taj Mahal is. We know Taj Mahal is made of limestone, which is CaCO3, marble stone, that combines with H2SO4, acid rain, to form CaSO4 plus H2O and CO. So due to the formation of CaSO4, the Taj Mahal will be damaged. So CaCO, the marble stone reacts with acid rain. Acid rains contain concentrated acids like H2SO4 and HNO3. H2SO4 interacts with marble stone to form CaSO4 H2O CO2. So this reaction is mainly responsible for damage of Taj Mahal. Option A, it is strong acid. It damages marble stone. So this is the end of the chapter. So next video I will explain one more chapter. All the best and thank you.